Hi, my name is Abby Roberts, and I'm going to be doing my presentation over heat. Heat, temperature, and thermal energy are all items that are considered closely related. They are all closely related in terms of temperature as well as energy. This presentation's purpose is to help discern how they are related, how they are different, and how they are used in the world we live in, as well as to tell you the differences between the scales that we use in temperature. Let's start with the first term, heat. Heat is the transfer of energy from a higher temperature object to a lower temperature object from the physics classroom. Let's discuss this in a way to easily understand the term heat. Say you made a cup of hot chocolate with water that you then boiled on the stove. So the water is at a temperature of 212 degrees Fahrenheit when boiling, and then you put it in the mug and pour in the mixture. So here we have our cup of hot cocoa. If you are smart, you will then let the hot cocoa cool down before you drink it. The cooling down in this is an example of the energy being transferred from the water through the mug and then into the surroundings. So here we have the counter it is sitting on. We'll let the steam. And here's the air around it. The surroundings would be considered the countertop that the mug is sitting on, as well as the air surrounding the cup. This could also work in the opposite direction. If you were sitting there trying to eat some ice cream on a hot day, you could almost visually see the change. So here we're going to draw ice cream. Ice cream is generally served at the temperature range of 6 to 10 degrees Fahrenheit. This comes from the International Dairy Food Association. The temperature outside is about 95 degrees Fahrenheit. You would have to eat the ice cream fast because the energy from the surrounding air, as well as your body heat from eating and holding the ice cream, will quickly begin to melt the ice cream. Therefore, heat is not something that we would contain in any type of container, but it is actually how energy is being transferred between any two objects, which leads us to understanding temperature. Temperature could be described as a measure of the ability of a substance, or more generally, of any physical system to transfer heat energy to another physical system. This also comes from the physics classroom. Temperature is measured through taking the average of how fast the molecules are moving and how much heat they are putting out. So for our early example, with the molecules in the hot chocolate are going to be moving at a much faster speed than that of the ice cream. Therefore, their temperatures are going to be read differently. Temperature and heat are different, then, because temperature is the measurement of how fast the particles are moving, while heat is a measurement of the ability for the energy to be transferred. So how does thermal energy relate to all of this? Thermal energy refers to the energy contained within a system that is responsible for its temperature. Thermal energy is usually looked at as being the last part of measurable energy transfer before it is lost to the environment that it was in. Thermal energy is only the measurement of inside the system, not the transfer of the energy like heat. Take the hot chocolate, for example. Thermal energy is the measurement of the energy inside the cup. It does not measure how the heat is slowly getting colder due to the heat being transferred to the air and countertop. Thermal energy matters with how big the space being measured is. If you are trying to freeze a cup of water in a 30-gallon trash can, it's going to take more thermal energy to freeze the trash can than it would take to freeze the cup of water if they were both in the same freezing environment. Thermal energy is the total measurement of the kinetic energy, while temperature is the average measurement of the kinetic energy. While we are talking about temperatures, let's talk about the different measurements of temperature. We have three different types of commonly used measuring systems. They are Celsius, Fahrenheit, and Kelvin. Fahrenheit is a type of measurement that is used mostly in the United States and some parts of the Caribbean. Daniel Fahrenheit, a German scientist, created this system in the early 1700s. Fahrenheit did his scale after creating his mercury thermometer and realizing his thermometer was more accurate than any other thermometer that was created before, which happened to be an alcohol-based thermometer instead of mercury. He then started making his scale of temperature by measuring the degrees and doing some research. An interesting fact that I thought would intrigue you is that he was able to discern body temperature measurement by putting the thermometer under his wife's armpit and recording the results. He then figured out that from the old alcohol thermometer to the new thermometer using mercury, everything for the most part was just times by 4. This system was used until the 18th century when Celsius was created by the astronomer André Celsius. Celsius is also credited for being the first to make tools that could measure how bright stars are, as well as assess changes in Earth's magnetic field. Celsius is used in the rest of the world as a way to measure temperature. To convert Fahrenheit to Celsius, you take the initial degree, say 212 for boiling in Fahrenheit. So let's write that down here. We're going to have 212 Fahrenheit and subtract 32 from it. Now you take this number and divide it by 1.8, which then equals 100. Take all of this. Celsius. So then we get, the Kelvin system was created by the British scientist William Thomson, who was also referred to as Lord Kelvin. The Kelvin system is used as 0 being equal to the absolute zero. The absolute zero states which starts at the point where molecules stop moving altogether. This theory has not been fully achieved yet, but scientists have been able to get the degree as low as a fraction of a Kelvin. In the Kelvin system, the word degree is not actually used. Instead, the measurement would be shown as 0 Kelvin instead of 0 degrees Kelvin. So 0K would be written down to describe absolute zero. The Kelvin scale is used mostly in the world of science, especially because there are no negative numbers used in the Kelvin scale. Another interesting fact is that the Kelvin system could also be used as a way to measure the temperature in colors, which is usually referred to in light, such as in when a color goes from red to yellow, then to a blue-white. It is also increasing in temperature. Kelvin could be converted from Celsius if you take the temperature, which again we will use boiling, so 100 degrees Celsius. Celsius. And then you just simply add 273 to that. 273, which we will then get 373 Kelvin. So water would boil at a temperature of 373 Kelvin while using the Kelvin system. So after all of this information, I hope you could look at the world in a new light and see how important energy and heat is at such a complex but super basic level to every individual that is living. If there are any questions, feel free to email me and I would love to talk to you.